Hello guys, welcome to MAT1512, also known as Calculus A. Okay, here in front of me I have a previous exam paper from 2011. I'll just be doing some few questions with you. I hope you're ready, and assuming that you've studied and now you're preparing for your final examination May or November. Okay, if you look at the exam paper, if you look at the first question, okay, the first question here, guys, we have to find the limit as x approaches to of f at x if this is our f at x and it is a piecewise function. Okay, so my advice, guys, to do this, you can draw the function, but it's not necessary that you have to draw the function to do this, okay, especially to save time. But for now, I'll draw the function for you before I do the problem. Okay, so we have to draw this function. Okay, so we have f at x equals to x squared if x is smaller than 2. Okay, so let's go ahead and draw the function. Okay, my y there, my x. So x squared is parabola, but this parabola is defined when x is smaller than 2. So x is smaller than 2 there, and we know the parabola, this goes this way, but x defined when x is smaller than 2, therefore is defined, if that is 2, then the parabola is defined all the way. Okay, then put the corresponding y value there. What is the corresponding y value? If I substitute in my parabola, what is my output? My output is 4. 2 squared is 4. Okay, next one. If x is 2, y is 3. So if x is 2, y is 2. So shaded dot when x is 3. Okay, beautiful. Then we have a straight line, 3x minus 2, but this straight line is defined when x is bigger than 2. So we have a straight line. I mean, to draw the straight line, guys, I think our straight line, you can check yourself, will go from there all the way. Okay, because I can see if I input 2 to my straight line, it's 6, because 3 times 2 is 6, minus 2, I still get 4. There I have my piecewise function. I'll just label this is 3x minus 2, and this is my x squared. And what we have to do is to determine the limit as x approaches 2 of f at x. This is what we need. To do this, guys, we need the limit. To do this, we need the limit as x approaches 2 from the positive side of f at x must be the same as the limit as x approaches 2 from the negative side. Okay, so the limit, the 2 must happen. If the 2 not equal, then the limit does not exist. Okay, so let's look at x approaches 2 from the positive side by looking at our piecewise function. Okay, now if you look at this, 2 from the positive side, if I look at 2 from the positive side, which function I get closer to? I get closer to 3x minus 2. So what I can do is that lim as x approaches 2 from the positive side, we approach 3x minus 2. Then if I do this with my high school maths, okay, you get 3, 2 there, minus 2, okay. If you simplify that, which is 6 minus 2, which is 4. Okay, from the definition of a limit. Now, we have to do also lim as x approaches 2 from the negative side of 3x minus, oh sorry, this is wrong, I can't be doing that. So I need lem as x approaches 2 from the negative side. So from the negative side, if I look at this, it's like if I approach 2 from the negative side, if I get closer to 2 from the negative side, which function do I touch first? Is the parabola, the x squared. So I have to use the x squared there. If I do that, then I get 2 squared, and 2 squared is 4. Now you can see that the lim as x approach 2 from the positive side is the same as x from the negative side, which equals 2, 4. So if the limit from the left and the limit from the right equal to the same value, therefore we can conclude that this is equal to 4. Then if this 2 not equal, therefore the limit does not exist.